Welcome to Study Loop.
Okay, so this is problem 24.95, and this is actually a three-part question. So the first part is saying, suppose we have two polarizers, okay, and we actually ordered them in a way that actually the first one, the optical axis of the first one is at the right angle of the second one. And then we are shining the first polarizer with an unpolarized light. What will be the output after the second polarizer? So generally, if we have unpolarized light that is incident on a polarizer, after the polarizer we'll have just half of the intensity of the original light because it was randomly oriented in every direction, okay, and it will be polarized in the same direction as the optical axis of that polarizer. So after this first polarizer here, we'll have light that is polarized in this way, the same direction as this um, polarizer at the optical axis of this polarizer, and the intensity will be half the initial intensity. So it's I naught over 2. But now when it goes through the second polarizer, so the polarization direction of the light is actually perpendicular to the second polarizer, so it will not pass through the second polarizer. So the final, for the first part here, the final intensity I final is just 0. Okay. Now for the second part, it's saying that suppose instead of having these two polarizers in this way, we're going to insert a third polarizer in between them. Okay, so we're going to put a third polarizer here. Okay, and the axis of the polarization axis of this polarizer is tilted so that it actually makes an angle with the first polarizer, so the optical axis of the first polarizer, and this angle is 56 degrees. So what will be the final output here? So actually, as I said, after the first polarizer, intensity will be just half of so I1 after the first polarizer is just half of I naught because random was unpolarized, okay, and then after the second polarizer, I2 will be I1 times cosine square 56, which is I naught over 2 times cosine square 56. Now the light, after it goes through the second polarizer, it will be polarized in the same direction as the optical axis of the second polarizer. So when it goes through the third polarizer, the angle here will be 90 minus 56, which is 44. Okay, so I3 will be just I2 cosine square 44, which is I naught over 2 times cosine square 56 times cosine square 44, and this will give us the final answer, which is 0.08 I naught. So in the second case, when we have that third polarizer in between the first two polarizers, the final intensity will be 0.08 I naught. Okay. The third case is asking what if actually we have the third polarizer, the one that we already added here, actually before both of them. So the third polarizer will be moved towards here. What will happen? So again, after the light goes through this polarizer, okay, which is now here, okay, the intensity will be reduced to half, okay, so it would be I naught over 2, and the light will be polarized in the same direction as the optical axis. And then when it goes through this, the second polarizer here, the intensity will be reduced again, and it will be polarized in the same direction as the optical axis here. And so when it goes through the third one, which is perpendicular to this optical axis, it will not pass through it because the direction of the polarization will be perpendicular to the optical axis of the last polarizer. So for the third case here, again, I naught, I final is just 0. And the main reason is that it passes through two perpendicular polarizers successively. So the, the light cannot go through two polarizers that are at right angles to each other successively.